All right, here's my attempt at getting a LVOT measurement for a mitral valve and valve surgery, interventional procedure. Um, the, um, the key thing is to try to identify a plane across the LVOT where the device will potentially obstruct the LVOT. So you can see in this report that's been done already that the measurement of and cross section is measured not at the location that we typically do for TAVR, for example, but a measurement where the device will sit within the existing bioprosthetic mitral valve. The mechanical sort of struts or the stent that the new device will have is roughly, it looks like 2.5 centimeters. We can get exact dimensions, but they do try to seat the device on the existing biomechanical valve. So this is a valve-in-valve procedure, just to be clear. Now you can see that what the 3D tech has already done is line up a plane, a 3-chamber view, and an axis along the expected trajectory of that valve. Okay, so let's go ahead and get into that plane. To do that, we'll just center on the valve. I'm just going to link this, turn this into an MPR. There we go. Okay, so let me line up the axis of a 3-chamber. I'm just going to tilt this to a 3-chamber view. And you can see how heavily calcified the annulus is here. And all I have to do to get a 3-chamber is just tilt one of these planes in axis. This is a 3-chamber view already. Okay, so then once you're here, once you're in this view, this 3-chamber view, we basically need to project the length of the struts onto this plane, and which is also here, and guesstimate where that's going to be. It's roughly here, right? But we want to make our measurement in the LVOT. So we're going to move into the LVOT and then tilt roughly at that level of where we project that line. I'm sure there are some softwares that already do this automatically. And we want to choose a phase, of course, maybe an early systole or mid-systole where there's a little bit of less motion, to try to do that measurement on. So it's in this plane kind of difficult to figure out where the ends of the struts are, so we can try to back up to where we can see them. So if you see here, we're looking at the LVOT. Now there's a lot of calcification there, just sweeping back and forth, and a lot of potential places to measure, as you can see. But we're going to try to measure right where we project the ends of the struts to be. So that's going to be roughly around here. If that, hopefully that is clear to you also. And this certainly is a subject to error, right? Because if the device gets seated apically, that's going to be a different location than if the device gets seated towards the base. If it's too apical, it's more likely to obstruct the larger or more of the LVOT. So there are some limitations in this approach, but certainly we can give the measurement anyway. So this is roughly the shape of that. And I get about 520. When I've done this before, I got around 600, so it can vary depending on where you draw that measurement. And I think the outside port for this particular case was something like 590. So that's sort of the error bar of this measurement. I'll give it another shot just to see what the error bar is for me personally, even with the same plane. Try to trace it as well as I can. Oops, that didn't quite work. Let's try again. That's a little bit better than what I just did, I think. Something like that. So I got about 600. That's what I got the first time. I think I cut off the corner here too early on the previous version of this. But hopefully that's clear. That's pretty much what and they got 590, so it's not that different than what they measured on the outside.